So from the first video for problem number 4, we found the velocity function and the acceleration function based on the position function that was given initially. And now we want to figure out, well, where is the velocity equal to 0? We want to set up a sign chart for velocity and set up a sign chart for the acceleration. So the velocity is equal to 0 when this fraction is equal to 0. And when the fraction is equal to 0, it is equal to 0 when the numerator is equal to 0. So when either t plus 4 equals 0 or t minus 2 equals 0, and so that happens when t equals negative 4 and t is equal to positive 2. But when if we think about it, the t value, since we have a particle moving left and right, we have this, and when t starts at 0, this t value equaling negative 4, that's an extraneous solution in this context of t starting at 0. So we can start our sign chart at 0 because that's where t starts, and then at the t value of 2 we know that the velocity is equal to 0, and when the velocity is equal to 0 we know the particle is stopped. And so we know, though, that when the velocity is negative, the velocity particle's moving left, and the velocity is positive, particle's moving to the right. So that's what we have to determine here. So on the interval, this is the v of t sign chart. On the interval from 0 to 2, we just pick a test value like 1. If we replace t in the velocity function with 1, we're gonna find that the first factor, 1 plus 4, is positive. The second factor, 1 minus 2, is negative, and then the denominator will always be positive. 1 plus 1 squared, anything squared is going to be positive. And then, so we get only one negative in there, so therefore the velocity on the interval from t equals 0 to t equals 2 is negative. On the interval from 2 to infinity, we can replace t with any number greater than 2, and we can see that all of the factors are positive. Positive times positive over positive, and so therefore the particle would be moving to the right from 2 through infinity, and the particle is moving left from 0 to 2. And then we have to determine we find the sign chart. We have to create a sign chart for the acceleration, and when we do that, we're going to look at the acceleration being 18 over t plus 1 cubed. Now when you look at 18 over t plus 1 cubed, the one thing you should be noticing here is if t starts at 0 and you take 0 plus 1, or you take any number greater than 0 and you add 1, and then you cube that number, well, the denominator is always going to be positive, and clearly 18 being a positive number means that you have a positive divided by a positive. And so the acceleration function never changes sign. It's always positive. I don't need to write all these plus signs, but just figured I'd do that. And so if the acceleration is always positive, that means the pushing motion would be always to the right. And when that interacts with the velocity function, we can see where the particle is speeding up and slowing down. So we have everything we need to describe the motion of the particle. So the motion would be the next part. Motion on the interval from 0 to infinity. This is a 2, time t equals 2 seconds. So from time t equals 0 to time t equals 2, we can see the velocity is negative and the acceleration is positive. When we have that, we know that the particle is slowing down. And then on the interval from t equals 2 to infinity, we can see that the velocity is positive and the acceleration is positive. So when the velocity and the acceleration have the same sign, we know that the particle is speeding up. Speeding up. So it makes sense. Slowing down, moving left, and again, we should have written that here. So we have slowing down and moving left, and speeding up and moving right. And it's easier to see when we describe the position. So we have one more chart to describe position. And the position, we want to set up a number line because that's exactly what it says it's doing. It's moving left and right on a number line. And the position, we have key times. We have the position at 0. We have the position at 2. That's it. So we have 0 and 2. And what is the position at 0? Well, when we replace t with 0 in the position function, we get s of 0 equals 0 plus 9 over 0 plus 1 plus 1. So we have 9 plus 1 is 10. So the position at 0 is 10, and the position at 2 is we replace t with 2, and we get 2 plus 9 over 2 plus 1, and then plus 1. So we get 2 plus 9 over 3, which is 3, plus 1. So we get 5 plus 1 is 6. So the position at time t equals 0 is 10. At t equals 0, we have the position right there at 10, and then the position of the object at t equals, I should write that here, t equals 0, and then at time t equals 2, the particle has moved to the left and it stopped. Remember, at t equals 2, the particle stopped. We said moving left and slowing down. So the particle at time t equals 0, the velocity, we could figure that out. Velocity was -8, and velocity is -8. So it was already moving left. So when the time started, the particle was moving left. It continued to move left and slowing down until it got to, hold on, my iPad is telling me something. Okay, particles moving, I got to speed up here because it's telling me I'm out of storage. Moving left and slowing down, then it gets to this point here at position 6, and it stops, moves to, and it starts moving to the right, and it starts speeding up, and it's speeding up forever, and it just keeps going on forever to the right. And that's it.